In this video, we're going to look at why the flip and multiply procedure works when dividing fractions. And let's begin by reviewing what a reciprocal is. So let's say you have a fraction 3/4. The reciprocal is where you have the numerator and the denominator switch places. So the reciprocal of 3/4 would be equal to 4/3. And the product of a fraction and its reciprocal is always equal to 1/2. Because the numerator times the new numerator is 12, and the denominator times the new denominator is also 12, we get 12 over 12, which is 1/2. And this will work for any fraction, even if you have an improper fraction like 5/2. Its reciprocal is 2 over 5. And again, when you multiply the numerator times the new numerator and the denominator times the new denominator, you're going to get the same number on the top and on the bottom, which means you have a fraction equal to 1. So now let's look at some division. Let's say we have 3/4 divided by 1/2. We can write this as a complex fraction, 3/4 over 1/2, because fractions really are just division problems. So at the top right here, we have 3/4 and we're dividing it by 1/2. And now we know that when we multiply a fraction by its reciprocal, we get 1/2. So if we take the bottom of this fraction right here, the denominator of this complex fraction right here, if we take the denominator of this fraction, we multiply just the denominator by its reciprocal, which would be 2 over 1, we know that we should get 1/2. And now if I do that same procedure to the numerator of my complex fraction, what I've really done here is I've multiplied my original complex fraction by 1/2, because right here we have 2 divided by 1, which is 2, and right here we have 2 divided by 1, which is 2. So this, in this blue box right here, we really have 2 over 2, which is 1/2. And I know that when I multiply any fraction by 1/2, or any number by 1/2 for that matter, the identity property of multiplication says we get an equivalent number. We don't change the number that we begin with. We get the same number, but it may look different. In a fraction, we call that an equivalent fraction. So if I go ahead and finish my multiplication problem right here, in the numerator, I would then have 3/4 times 2 over 1. And then in the denominator, I would have 1/2. And I know that when I divide by 1/2, I don't change the value of anything. So I can rewrite this entire problem as 3/4 times 2 over 1. And if we now go back to our original problem, 3/4 divided by 1/2, we have proved that dividing fractions is equivalent to multiplying by the reciprocal of the divisor. 1/2 is the divisor, 2 over 1 is its reciprocal, and we proved that right up here. We can now also use algebra to prove that this works in every case of dividing fractions. So if we have a fraction a over b, and we're dividing it by a fraction c over d, we can rewrite this as a over b divided by c over d. Now we have a complex fraction. We can then multiply the numerator and the denominator by the reciprocal of the denominator. So that would be d over c and d over c. When we multiply this out, we get, for the numerator, a over b times d over c. And for the denominator, we're multiplying a fraction times its reciprocal, so we get 1/2. So when we simplify this, we get a over b times d over c. And we've proven that our original division problem is exactly equal to taking the dividend and multiplying it by the reciprocal of the divisor.